Alright, so in this video, I'm going to solve the equation 9 to the power of x plus 9 to the power of x plus 9 to the power of x is equal to 999. So to solve this, I'm going to first start by factoring out 9 to the power of x on my left-hand side. So I get 9 to the power of x times 1 plus 1 plus 1 is equal to 999. Now 1 plus 1 plus 1 is 3, so I get 9 to the power of x times 3 is equal to 999. From here, I'm going to divide both sides by 3. So these two cancel out, and I get 9 to the power of x is equal to 999 divided by 3, which is 333. Alright, so from here, I'm going to take the log on both sides. So I get log 9 to the power of x is equal to log 333. And if I have something in the form log a to the power of b, this is equal to b times log a. So log 9 to the power of x, I can move the x to the front. So I get x times log 9, which is equal to log 333. From here, I'm going to divide both sides by log 9 because we obviously want to isolate x. So these two cancel out, and I get x is equal to log of 333 over log 9. Now, I can rewrite log of 333 as log of 3 times 111. And I can rewrite log of 9 as log of 3 squared. Now, we know that if I have something in the form log a to the power of b, I can move b to the front. Another property of logarithms is that if I have something in the form log a times b, this is equal to log a plus log b. So I get x is equal to log 3 plus log 111 over 2 times log 3. And this is equal to log of 3 over 2 times log 3 plus log of 111 over 2 times log 3. So now these two cancel out, and I get x is equal to 1/2 plus log of 111 over 2 times 3, log 3. So now log of 111 is equal to 2.045. So I get x is equal to 1/2 plus 2.045 over 2 times log 3. And log 3 now is equal to 0.301. So I get x is equal to 1/2 plus 2.045 over 2 times 0.301, which is 0.602. So now log of 111, which is 2.05, divided by 0.602 is equal to 3.397, which is the same thing as 3.40. So if I add 1/2 to this, I get 3.90 as my solution. Alright, so in this video, I'm going to solve the equation 16 to the power of x is equal to x to the power of 2. So to solve this, I'm going to first start by taking the power of 1 over 2x on both sides. So I get 16 to the power of x to the power of 1 over 2x is equal to x to the power of 2 to the power of 1 over 2x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So we can use this property for both of these terms. 16 to the power of x to the power of 1 over 2x is equal to 16 to the power of x times 1 over 2x. And x to the power of 2 to the power of 1 over 2x is equal to x to the power of 2 times 1 over 2x. Now, the x and x cancel out on my left-hand side because they multiply out. So I'm left with 16 to the power of 1/2 on my left-hand side. And for my right-hand side, the 2's cancel out. So I'm left with x to the power of 1 over x. Now, my goal is to turn the left side to be in the form some number to the power of 1 over that number, so we can make that number our solution. Well, right now, this means that 16 and 2 have to turn into the same number. So we need to rearrange this so that 16 and 2 are the same number. So to do that, (16) is the same thing as 4 squared. So I'm going to rewrite it as 4 squared. So I have 4 squared to the power of 1/2 is equal to x to the power of 1 over x. And now remember, these two multiply. 2 times 1/2 is just 1. So I'm left with 4 is equal to x to the power of 1 over x. Now 4 is the same thing as -2 squared. And 2, our exponent here, I can rewrite as 1 over -1/2. And I have this times -1. So I have 1 over -1/2 times -1. And remember, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So this -1, I'm going to move to be an exponent of -2. So I get -2 to the power of -1 to the power of 1 over -1/2 is equal to x to the power of 1 over x. And -2 to the power of -1 is 1 over -2. So my solution here is -1/2.